Lipids are a class of substances that are insoluble in polar solvents, such as water, but soluble in nonpolar substances, such as ether. They're a diverse group of organic compounds lumped together because they do not interact appreciably with water. Lipids encompass molecules such as fatty acids and their derivatives, including tri-, di-, and monoglycerides. Lipids include triglycerides, which make up fats, oils, and waxes, which are found in your blood. When you eat, your body converts calories it doesn't use right away into triglycerides. The triglycerides are stored in your fat cells. Later, hormones release triglycerides for energy between meals. So here you can see a triglyceride. It consists of a glycerol backbone, which is shown here, with 3 fatty acids. Fatty acid is a carboxylic acid with a long chain, which is either saturated or unsaturated. So for example, here we have palmitic acid. This is a saturated fatty acid. The reason it's considered to be saturated is because there's no carbon double bonds between carbon atoms. So in other words, this molecule is completely saturated with as much hydrogen as possible. We have oleic acid. This is a monounsaturated fatty acid. This has 1 double bond in this hydrocarbon tail and 2 fewer hydrogens. And we have linolenic acid here, a polyunsaturated fatty acid. It has multiple double bonds and correspondingly fewer hydrogen ions. Okay, use the chemical formula given to decide which of the following fatty acids is the most unsaturated. Okay, let's move on to the next topic. Double bonds between carbon atoms cause a kink in the chain. So here's oleic acid, a monounsaturated fatty acid. Due to this 1 double bond here, it's no longer straight. If it was fully saturated, this would be perfectly straight. The hydrocarbon tail would be perfectly straight, but because of this, there's a kink. So which is most likely to be solid at room temperature? Polyunsaturated fats, monounsaturated fats, or saturated fats? Okay, glycerol plus 2 fatty acids produces a blank. Okay, lipids also encompass phospholipids, which consist of 2 fatty acids and a phosphate group, as you can see here. So phospholipids are extremely important. The fatty acid tails of the phospholipids are nonpolar and hydrophobic, and the glycerol and phosphate heads are polar and hydrophilic. So that often if you look, if you have a number of phospholipids, they'll arrange themselves spontaneously into this sort of a form in which the hydrophobic tails of the phospholipids face inwards towards each other, and the hydrophilic heads face say an intracellular, if this was a cell membrane, towards the intracellular compartment of the cell. And there's a second layer here, so this is a bilayer of, again, of phospholipids in which the polar head faces outward towards the extracellular space. And so this whole thing is called a phosphobilayer. And so you could make an artificial phospholipid bilayer like this, and it resembles in many ways a cell membrane. Of course, a true cell membrane would have a lot of protein in it, but the basis of a membrane is in fact this phospholipid bilayer. And you'll note again that it has hydrophilic heads and then a region of hydrophobicity in the middle due to these hydrophobic tails. And that turns out to be extremely important. It turns out that certain things like ions, which are hydrophilic, do not pass easily through this hydrophobic core of a lipid bilayer. Okay, as I said, lipids are sort of a lot of different substances that are sort of grouped together because of the fact that they're hydrophobic. So lipids also encompass metabolites such as cholesterol and steroid hormones. Most steroid hormones are derived from cholesterol. Cholesterol is very important also for membrane fluidity. So within a membrane, let's go back, You'll find cholesterol in between these phospholipid tails, and they actually break up the regularity of the phospholipid tails here, and so that actually increases membrane fluidity. The more cholesterol there is, the more fluid the membrane is. Shown here is cholesterol. So again, it's the primary source of material for steroids in the human body. And here's the steroid hormone, cortisol, which is involved in the stress response. Lipids also encompass eicosanoids. Eicosanoids are derived from fatty acids and have a variety of effects in your body. For example, they play a role in inflammation, fever promotion, blood pressure regulation, and blood clotting. They also influence the immune response and certain respiratory and reproductive processes.